All right, how you guys doing out there today? This is Mr. Muscarella coming at you, and in this video, I'm going to show you guys how to solve trig equations. This is going to be the easiest level. Level 1, I'll call them. So first, let's go ahead and get into a nice little warm-up. Now for our warm-up, we're just going to take a look at these two problems here. You can probably do these without me, so just go ahead and hit pause, then come on back, and let's see how you did. All right, my mathletes, how did we do on that? Hopefully, you got x equals 1/2 for the first one. Now, you don't have to necessarily show this middle step because some of you are at this level where you know -4 divided by -8 is positive 1/2. So you could skip that step that I highlighted there and get right to x equals 1/2. But what I do want you to pay attention to, equal signs. Nice, neat, organized, one lined up right on top of the other. Now let's take a look at example 2. And in this one, again, we're going to take a look at subtracting 2 from both sides. Now, when you move from this line to this line right here, both sides, what I want you to do is think about this thing. We're going to use the word reciprocal. Okay, you're going to take the reciprocal of each side to help us solve for x. This is one technique you can use to do this rather than cross multiply. So if you take the reciprocal of 1 over x, that becomes x. And the reciprocal of 3, remember 3 is the same thing as 3 over 1. So when you take the reciprocal of 3 over 1, that becomes 1/3. Be careful. Don't confuse that with a negative reciprocal where you would do the same thing, but then change the sign of the value that you're working with. So the sign stays the same and you just flip it. All right, so that's a quick introduction, quick warm-up to what we're going to do today with solving trig equations. So now on to our show. There's going to be 4 examples, and what you might want to do is grab a unit circle. If you don't have one, print one out or have one up nearby, because that is going to be most handy. Now, the other thing you might not want, or the other thing you might want to have handy is the reciprocal values from around the unit circle, paying attention to the plus or minus. And these are some things, of course, that we've covered in class before. Now, with your unit circle, it will, of course, be handy to have the values for tangent on there as well. So if you forget those, just remember this pattern. 1 is going to be here at pi over 4 and over here at 5 pi over 4. Both 3 pi over 4 and 7 pi over 4, both of those values will be -1. Here at pi over 6, you're going to have square root of 3 over 3, and then the same thing over here at 7 pi over 6, square root of 3 over 3. And of course, you're going to have square root of 3 for pi over 3, and over here at 2 pi over 3, you're going to have negative square root of 3. Down at 5 pi over 6, you're going to have negative square root of 3 over 3. And then down here at 4 pi over 3, we will have square root of 3. And then over at 5 pi over 3, we're going to have the value of square root of 3 again, but negative. And at 11 pi over 6, we're going to have negative square root of 3 over 3. Now at the axes at 0, 90, 180, and 270, 360, at those values, remember, tangent is going to be 0 on the x-axis, on this side, and of course, at 90 and 270, tangent is going to be undefined. So those will be some things that will come in handy as we work with solving trig equations. So make sure you have that down, and then the other piece, of course, are the reciprocal values around the unit circle. Because sometimes when we're finding one of the reciprocal trig functions, so the reciprocal of sine, so remember these, the reciprocal of sine, that's the same thing as 1 over cosecant. And the reciprocal of cosine is the same thing as 1 over secant. And tangent, the reciprocal of tangent, of course, is cotangent. So that'd be 1 over cotangent. And likewise, the reciprocals of secant, cosecant, and cotangent are going to be 1 over sine, 1 over cosine, 1 over tangent as well. So that goes both ways with that. But anyway, let's go ahead and get on to solving our trig equations. All right, so here we are, and we're going to take a look at our first example. Not too bad. We're just going to go through 4. Now, the first example, very straightforward. We're trying to solve the equation 1 minus cosine of theta equals -3. Now the goal here is to find what value of theta on the unit circle that is between 0 and 2 pi. So this is going to come into play here. 2 pi we wouldn't include because of our inequality symbol, because we don't include the -2. So more on that later, or we don't include 2 pi. All right, so that is going to be coming up shortly. Let's just start the algebra behind example 1. First, subtract 1 on both sides. Again, keeping our equal signs nice and neat and lined up, we'll end up with -8 cosine of theta equals -4. Dividing both sides by -4 is going to give us cosine of theta as 1/2. Now here's what I have to also remember. Cosine is my x-coordinate on the unit circle. So then I have to go over to my unit circle and say, hello unit circle, where, oh where are you going to be 1/2? And that's going to be at 2 different spots. One of them is going to be right here at pi over 3. And the other spot is going to be at 5 pi over 3. So in both of those cases, the value of theta is 1/2. So when I go to write my answer for that, I would say theta equals pi over 3 and 5 pi over 3. Now some textbooks might write it like this. They might write theta equals, instead of an equal sign, they'll just use the brace for it. So another way you could write this is pi over 3 and then 5 pi over 3 with a little brace around it. Either way, you're okay. Now let's take a look at example number 2. If you got this, go ahead and hit pause. I think you probably might be able to do example 2 on your own. For those of you who want more, let's go ahead together. So -6 sine of theta equals -3. Dividing both sides by -6, we get the sine theta. Again is going to give us a 1/2 value. So now I want sine. Sine is my y-coordinate. Where is the y-coordinate 1/2? Well, one of those is right here at 5 pi over 6. The other one is right here at pi over 6. So those two values are where the sine is 1/2. So again, we just write our answer simply like this. Theta equals pi over 6 and 5 pi over 6. And that's it. Not too bad, pretty straightforward so far. Now, let's take a look at examples 3 and 4. To start example 3, first divide both sides by -6. So we'll get cotangent of theta equals 2 square root of 3 over -6. Now, some of you might be okay there on that first step, and you may be able to skip that and do the simplifying in your head, but when you do that, you'll get negative square root of 3 over 3. So when I look at this, if I don't have that spot memorized on the unit circle, then I'm going to have to go here and say, well, what's the reciprocal of cotangent? So we're going to take the reciprocal of cotangent, which is 1 over tangent. And that's all we do for the left side. For the right side, we haven't touched that at all yet. Now we're going to take the reciprocal of both sides simultaneously. So when we do that, we'll end up with tangent of theta on the left side. And on the right side, when we take the reciprocal of negative square root of 3 over 3, remember, the negative sign is going to stay there. We don't drop the negative sign. And 3 is going to go on top, and square root of 3 will be on the bottom. Now we have to be really careful here. Some of you might actually already know this and be able to do this real quickly and easily, but we can't have a square root of 3 on the bottom. So again, we're going to have to rationalize that. So multiply the top and the bottom by square root of 3 over 3. But wait, we're not done. So when we do that, tangent of theta is going to be equal to, and I'm going to do this a long way, square root of 3, negative 3 square roots of 3 over, when you multiply the two square roots of 3 here on the denominator, you're going to end up with, so these two multiplied together just give you a regular old 3. But wait, there's more. Then you have to divide these 3's. So your final answer is negative square root of 3. Oh boy. Oh boy. Now we could have saved ourselves some time here if we would have recognized in these two lines right here, when I go to take the reciprocal of 1 over tangent, or to flip 1 over tangent and put tangent on the top, I could have taken this negative square root of 3 over 3 and gone right to there if I have that part memorized. Just don't forget the negative sign. So that could have been another approach that you would take to solving this problem. All right, so just a little bit to think about there. All right, last example here. Let's take a look at example number 4. This time we have secant of theta. 3 minus 2 gives us 1. Reciprocal of secant. is cosine. So 1 over cosine of theta equals 1. When I take the reciprocal of 1 over cosine to become cosine, so I flip that side, and then I'm going to have to flip the other side, the right side. When you take the reciprocal of 1, well, that's still 1. All right, so not a big deal there. So I get cosine of theta is 1, and when I look on the unit circle, there's one spot where that happens, and that's right here at 0 or 2 pi. But remember, I cannot include 2 pi because of the directions. The direction said that theta had to be between 0 and 2 pi, but underneath the between 0 is less than equal to theta is less than 2 pi. So because this did not include the equal sign underneath it, we can't use that. So my only answer for that one is just plain old 0. And that's it. So there's a little bit of information to get you started on solving trig equations. And I hope you found this helpful. And I look forward to seeing you guys soon. Have a wonderful day, my mathletes, and I will catch up with you later. Peace out.